All right, welcome to the class 5, I think, of the live stairways, where we're going through the stairway to DAX and Power BI. So this is the 5th class. If you haven't seen the other classes, then they are on the Redgate Hub, and actually I should probably show that really quickly. So in the community circle, we have these classes available for now. They may be different over time, but DAX and Power BI is here, and the first 4 classes are linked here as well, and so you can catch up on any of those previous ones if you want. Now, in the first class, we got started. In the second class, we went through a couple of lessons. In the third class, went through a couple more. In the fourth class, we got through the sum item. I was hoping to get through more, but we had a little bit of a challenge in working through the sum. So in this class, I'm hoping that we can get through average, count, and possibly max in terms of what's actually happening here. So I think I'm going to try to go about 45 minutes in this class, and we'll see where we stand. So let's look at the average. So as with most of these articles, there's a general discussion of what's going to be covered, right? We're going to discuss function iterator pairs again as we go through average and AverageX. Look at syntax, and we'll see some examples. This preparation section, we've done most of this. It's repeated in case this is the first item you get into. And then this section on the average function is where we're really going to start. So average is a mean. It's an arithmetic mean. So if I take 1 and 2, the average of that is 1.5. If I take 1, 2, and 3, then the total there is 6, and the average would be 2 because I'm dividing by 3 there. So that's what we're essentially doing. So average says when many of us have worked with this in Excel, and we've gone through that. So average value is numeric value reside in a column and returns an average or a mean, which is the mathematical term, for the values. Now, if there are no rows to average, it returns a blank. That's interesting because in many mathematical functions, we actually get an error. Certainly we do in SQL if there's no items to do. As a matter of fact, I wonder, where's my SQL? So if I create a new query here, and let's just do something. Let's do a select the average from, and what we'll do is we'll do A of n here. So we'll get the average of n. And what we'll do here is we'll go values, and let's do 1, 2, 3. Okay. So if I look at that, average, it's 2, which is what we expect. But what if I did values of null? Get rid of this. Null is invalid for the average operator. So what if I did a blank? It's invalid as well. So the only thing I can really do here is 0. In that case, I get a 0 back. So if there's no rows, that's interesting. Let's create a quick table test, and we'll do ID of int, and then we'll run this. Okay, and so we'll select average from test. And ID that I did? Yeah, it's ID. So I get a null back, not a blank. So in SQL, we're really looking for actual values here. Now, if rows exist but none meet the criteria, then we get a 0. If we get non-numerical values, then we get average ignores empty cells or logical values. So that's interesting. Let's see how that works if we're going to do that. When we play average across date value, the result is a serial number. No averaging action can be accomplished for a column that contains text. And in such cases, average returns blanks. So I'm glad that this is one of those things to know that average isn't going to error out if I've got unclean data, if I've got mixed things in there. So, so zeros are added to the numerical total, which is what we'd expect. If there's a 0 in the value of a 0 in a test, that should affect your average there. So average works across all the values in a column. So it's an average there. If we need to do a subset of the table, then AverageX would be the thing that we want to use. So in going through the discussion, which hopefully you've read, if you haven't read this, pause this and read it, please. But what we really want to do is we get a decimal number that gives us an average. And so we can use that within columns or measures or within other functions as well, which is what we expect, right? DAX allows us to build functions on functions and that include those in some visual in Power BI. So AverageX takes an expression, which is evaluated for every row in the table. And that's where it's an iterator because it's working through row by row in a way that is still efficient, unlike what we get in SQL if we're using a cursor and going row by row. So as we had before, the average takes a column here as the argument. So this is in Excel. So in Power BI, it's slightly different how this occurs. But we can create a column that uses the average of some other column. And in this case, as you see, we're saying product standard cost. So I have all these values that are listed here in the second column. They are averaged to give me this value in the third column, which is the average value. Now this is repeated for every row, so we have to be careful of that sum of sums or average of average or things there. So we want to be careful of that as we go forward. For AverageX, we take an expression that's evaluated for every row in the table. So then we can filter or subset out the table and then use that as the expression. So this is average is still an aggregate function, which makes sense. It's this average, just like sum, count, max, min, etc. As expected, if there's no rows, the average returns a blank. If there are rows that are filtered out with the expression, they don't meet the criteria, we get a 0. And then non-numeric values are ignored. So that's good. So we'll skip over some of this here. So AverageX is for when we filter table, which is, boy, I think that's a very common thing I'd want to do, but we'll see. So the syntax is table and the expression, and then the average is computed for that, or the mean is computed for that. I grew up learning average, even though really I wish we would have been taught mean at the very beginning. So this is an iterator. So AverageX is taking this table, and then the expression is the sales amount plus the tax amount, and then that will be averaged together or meaned together. All right, and so this case, sales amount plus tax amount, these first two columns are added up, and then all of those values are summed, and then we create a mean, which would be $1,400. So that's interesting. So let's see if that works. So in practice, what we'll do is we'll start with the calculated column. So we want to go to internet sales. Before I do that, in my table, let's close this window. Sorry, in my database, AdventureWorks DW, I actually had this table, and it's listed here, that I created in the last class. So these were the values that we created where I just added some small values that are easy for us to see in terms of, let's put that back, in terms of what's going on. So 10 plus 1 plus 2 is 13, and that's repeated. Because of the average not working on non-numeric values, I decided to just try something else. So I added a character value column, then I updated that, and then I put some values in there. So you can see that most of these match the sale total. And in this case, I don't have the value. Now I have to pull that back into Power BI. So if I were to come to my model and I have this sales sample, what I could do is delete that out because, well, there's probably a refresh way to do this, but I don't know what that is. So instead I'm going to do is I'm going to say get data from SQL Server. We're going to connect back into my local instance, which is 2017. I'm not going to try to remember the database name exactly. And then what I'll do here is we'll pick that database and then we'll go find that table again and we'll import that. So we're not going to transform it, but this time we'll import it. And now we should have that character column in here. I think one of the things I do need to learn in Power BI is how could I update my model from the table, because this data is loaded. I would like to think there's some way to update this. So in sales sample, we see different things here. So in our article, let's go back here. We're going to add a computed column, and he's going to use this from the sales amount. Before we do that, I want to add one here. So I'm going to say a new column, and we'll give this a name that maybe is easy to understand. So we'll call this the numerical average, and we'll call this the average. And what we'll do is we'll take the sale total column here, and we'll close out the average, and we'll put that down there. And so that should give me an average of these numbers. All right, so if I were to take those numbers, where are they at? Let's do this. Let's open up Excel. Let's just add these up so that we can see how this works. So if I paste these in there, and of course they don't paste exactly. There we go. So the sum of these is easy enough to compute, and it's 6 values there. And here we'll say the average of these values. Now all this is simple math. It should work out. I should trust things. But I just wanted to kind of show, right, that here's my sum. Here is what the average means. And then here's the function. So 45.5 is what we expect there. And in Power BI, that's exactly what we see. Now, let's in fact add another new column, and let's see what we get here. So in this case, I'm going to call this the character average equals the average, and we're going to go sales sample. And we're going to pick the character total. Now in SQL, I have this NA character value. I wouldn't be able to implicitly convert that to a number. So in this case, though, what does Power BI do? Well, we think from the reading it should ignore that, but it in fact doesn't here. And so I've got a type string, so average isn't valid here. So that's an interesting thing to know, that it's not, while I could have values that are problematic perhaps in my numerical column, can't work with a type of string. So that's good to know. So let's in fact delete this column and move forward with what we were doing. Yeah, we'll delete that. So in Bill's article, as we look through average, the first thing we are going to do is that for internet sales, we're going to create a new column. And the new column, he's inserting a column, so we don't want to do that. We're going to say, let's do the average, and I'm going down here, of extended sales amount. So that's what he's trying to do. So in fact, we can just copy this at the equal sign, and he'll call it average internet sales. So we can't insert a column here, like that's not an item here to insert one, but we can say new column, which we'll put it at the end. So once this pops open, I'm going to put in this formula, and then what I'm going to do is come back here and go average internet sales, and extended sales amount. So if that's correct, if we've added this correctly, then we should get an amount that is the average of everything, which is $486. And that's indeed what Bill finds in Excel. He's using Power Pivot in Excel, we're using Power BI. So AverageX is the Iterator version of average. So in this case, whatever we want to do will be evaluated row by row. So again, he's inserting a column, and he wants this to be, he's going to say the AverageX of internet sales, which is what we want. But what's he going to do? So he's going to average total product cost. Oh, he's going to do sales amount minus cost. So this is going to be some sort of profit margin type thing we're getting. So is that the final one? We're going to rename it to average gross margin. So let's try this. So average gross margin. Let's create a new column at the end. Average gross margin. I'm not trying to be exact here. I don't need the quotes here in this count, but I do need. Do I need those? I don't know if I need in the same table. Does it calculate that correctly? Let's see. So our average gross margin is 200, which is what he sees. Yep, 200.02, which is what we have, 200.0213. So we have a little more precision that's shown in our model. So one more example, another calculated column. Let's add that to our other table. So I'm going to go drop out internet sales, and I'm going to do AverageX here. So let's say a new column here. And we'll call this the additional cost. And this is the average X of sales sample. And what we'll do here is we'll do sale freight plus sale tax. Is that what I'm doing? Amount, tax, freight. Yes, just those guys. So what's the average amount that we're adding on top of a sale? And so $10.50. So if we were to look at these numbers here, right, it's 3 and 6 is 9 and 9 is 18 and 22, 30, 30, and then 45, 55, 57, 63 divided by 6 is about 10. So that seems to be right, 10.5. So I'm getting just the average there. But you'll notice that I'm not here because I can add in an expression. I can change what this works. It's not just a single column. So what is the last example? We're going to insert a column, and the formula we're going to actually use here is based on filtering. So this is where the advantage comes in of the Iterator columns, that rather than using a table, I can include a filter for a particular item. So we want to filter, we're adding this to reseller sales. We're going to add it to our sample table first, and then we'll do it to reseller sales. So in this case, he's going to say for only a particular order. So let me say new column here. And we'll try another AverageX expression here. We're going to say expensive average sale is equal to AverageX, and we're going to say filter sales sample, and what we're going to do is say sale freight, sales sample, sale freight greater than or equal to 10. So that's the filter. So in that case, I'm only going to get those last two rows in my table because those are the only rows that will be there. And so then what we're going to do is we're going to do the sale total, which is here. And so what should be the average of my sale total for these two rows? Well, it's 143, so it'll be about 70 something. So what do we get there? Well, that's what we get, right? 71.5, which would be 143 when you double it. But again, I'm getting this for every row. So even though it's only these two rows, these bottom two rows here, which I can't select, but these two rows, I'm getting the average, but it's just appearing everywhere else. So that's where I have to be careful about using this in a column expression. So in this case, Bill's trying to show that the average is there, and I believe we're going to see it's only 2100 for this particular order. He's going to filter those and copy those over and put them in there and prove that the average actually works. I think we kind of did that with our mini calculation and our sales sample, because it's rather than having all these strange numbers, I have numbers that are easy to kind of average in my head. All right, but let's go ahead and see where this matters as a measure instead. So let's create a new measure, which is what we're going to do. Now, Bill's doing these in pivot tables. We'll actually get it into the visualization in a moment, but we can create the measure here first, and then we'll do it. So I'm going to ignore some of this pivot table stuff, and then I'm going to come down and say that we want to create a measure. So he's saying sum of average sales. This would be average of average internet sales then, is what he's adding in. Actually, maybe we want to see if this works in some sense. So let's come here. We're going to rename this to average. And then we're going to put a table here. And the things we're putting in here is a product, category, and subcategory. Let me just pop up here and see what we did here. And what's there? So that's proving the average works. And then for the pivot table, he's putting in the English product category name and English product subcategory name. So English product name, make this slightly bigger so I can see English product category name, and then the English product subcategory name. So we'll see, we get a similar view that he's getting here with the products. And now we want the internet sales, and we want that average internet sales. So let's come here. Average internet sales and average gross margin. Now he got those as sums, and then he just went ahead and changed it to averages, but our average is 46 and then various. We're not getting that. Why don't we get that? Oh, because it's summarized by, so no visualizations. If we were here, average and average. So 46 appears. Oh, he didn't change this one. And I got 7 million or something, right? So I'm saying the average here, but that's for all products, not these, because they're not filtered. So he's saying new calculated field. Can we do a calculated field? I would think that that's a measure, but we'll have to see what that actually is. Is he doing an AverageX here, or is he doing an average? Let's actually see what's going on here, and then we'll decide what's happening. He's doing an average calculated field. I don't know that I can add a calculated field here, can I? What if I did a quick measure? He said average per category. And the base value, what did he put in here? It's a sales amount. So internet sales. sales amount. And the categories would be the English product category name and the subname. And I don't know what I called that. Oh, there it is. Let's drop that in there. And what do we have? For accessories bike racks, it's saying 39,000. Is that right? Nope. Accessories bike racks should be 120. Do I have this set as a measure? That's interesting. Maybe we're not going to get through everything here. Because it's a measure, I'm not showing it as a sum or average. Average sale amount per subcategory. Maybe I need to change it by per category. Probably done something incorrect here, but calculated field isn't something that we see in Power BI as opposed to Power Pivot. So maybe that's something different that we're seeing there. Range. So there's something completely new that we're doing here in terms of setting this up. I can add a slicer and see if something different appears. So if I were to add a slicer and I put in the English product subcategory name here, and he had mountain bikes. So what do we see? And the average is 486. The average gross margin is still summed or average or something. Sale amount per the sub-product category name. I think I'm getting some sort of sum of sum there, which is probably an issue. That's an interesting one. I'm not exactly sure what I'm doing wrong there, what I'm getting. Because I should get $2,000. So we didn't create a measure in here, did we? Let's go back to where he creates this column. And so value, so the average Power Pivot, we'll create a calculated field, which I don't know what that is compared to a measure, honestly. I didn't completely go through this. I was thinking this was similar to a measure. Table name. And so the calculated field name will be average internet sales CF. The function is going to be the average function. Internet sales. Average of internet sales amount. Right, one column. And we'll close this. It's going to format as a number. And that's going to appear here. It's a pivot table field. Let's do something here. Let's go back to this. Let's get rid of this. And let's go in our model and create a measure. Let's just create a measure for internet sales. So I'm going to say a new measure, not a quick measure, just an actual measure. And we want this sales measure. I'm going to use the CM notation here. And I'm going to say AverageX of internet sales And we're going to say this is going to be the sales amount. I'm going to close this out. So average internet sales calculated measure. And now I'm going to drop that in my visualization. What do I say? $2,000, which is more in line with what we wanted here. For mountain bikes, what did we get? A lot of this is formatting and kind of arranging how things look in Excel. But once we go through here and we switch over, we see it's about 2002, which is what we have, 57. So that would round up. And if I were to get rid of this and look at all of these items, so accessories is $19. Totally, bike racks is $120. Yeah, $159. So that calculated field is similar to a calculated measure. So this is very much like what we did with the sum. So I can get that by using a measure, which avoids kind of this this value being in there for every single row, because this is summed up. So every row of accessories, I think, is being added into some of these, as opposed to the total average. This is more like what I would want to see. If I was actually building this to talk to a customer and we were trying to figure out what's our average internet sales, this is what we would want to do. And while they might be upset about this calculated measure, at least it lets me see what we're selling things for, right? Road bikes are not as expensive as mountain bikes, more expensive than touring bikes on average. If we're selling caps or gloves, they're not adding a lot in there. So this is a better look. All right, I think that makes some sense. Let's jump to the next article, which is count. So again, we have count as an aggregate, which is a column level item, and count X as the iterator. So we'll skip the preparation and we'll jump down here to where it says count. So the count function is going to look at how many items appear. So the number of cells in a column that contain numbers. So Power Pivot, I think, allows a blank in some of those numerical fields, whereas SQL would not. But we get a blank or a 0 as expected, similar types of things. So let's do some experimenting with our little table. So let's go into the model, and we'll go down to our sales sample table, and let's add a new column. And let's just experiment, because before we see what Bill does, let's kind of use the knowledge I've gotten from sum and average here. So we'll call this basic sale count equals count of, we give a column here. Let's just do sale amount. Like I could do the key, but the amount feels like something that might be more valid to me, right? In case there we got a row in there where there was nothing inside. So in this case, 6, right? There's six key values here, 6 sale amounts, there's sale. If I were to do a new column and do the count X, now remember in this case, we give it a table and an expression. So we do sale count, let's call it with freight. And what I'm going to do is I'm going to add another, I'm going to try to add another row here. So count X, so we'll do sales sample, and then what we'll do is we'll do sale freight greater than 2. It's a crazy expression, right? I was going to try to edit one of these to be 0, but I don't know that I want to do that right now. And cannot work with type values of type. Oh, so maybe I'm not understanding what the expression. Oh. No, I don't know what I would do there. If I just say sale freight, I'm going to get 6 again, I think. Where would I use count X? Probably a filter expression, right? That's where I would be doing this, because that's what I'm kind of missing. So table expression, and then something that's performed iteratively. So if it returns no. So what if I said, let's change this to be a filter. And now we're going to do sale freight greater than 100. Now, how many rows have a freight greater than 100? Well, 0. So in this case, what should I get back? Well, I should get a series of zeros. I get blanks because everything's filtered out. What if I said greater than 8? I should get 2, correct? I get 2 there. Why do I get a blank, though? That's an interesting one. Cells stay at 0. Rows exist, but none rows meet the criteria for counting. Well, none of these rows would exist out of the filter expression, so they would get no rows out. So I assume that that's why the blank is coming out, because it's equivalent of no rows whatsoever. All right, so let's look at the practice. So calculated columns, he's doing that. He's going to insert a count of product cost. And he gets $3.95, and he's doing this in product. So if we were to come to product and let's say insert a new column, and let's see, count product cost equals count product standard cost. Was that it? Yeah. It helps if you actually use the correct naming for these things. So if I do that, I should get, what did he get? 365, 395. And we get 395 as well. So we're following along. That makes sense. So now he wants to insert a column. This time he's going to say count X. And he's going to filter it, which is what we did. And he's going to do related. So let's do a new one here so that we can follow along. Error keys are bad in Power BI. Come on. I deleted it. Okay, new column. It's always a hassle, I think. I've got a fast machine. Power BI is going slow here today. Let's close some things. We won't save that. I did say new column, didn't I? Oh, there it is. Okay. So do count X, filter, and we'll do related table. Do product subcategory. I think I close it then, right? Related product subcategory. So I want to filter product. So we put product in here. Related table or related? Related. So I don't want related table. Say English product subcategory name. So that's the related portion of that. And we're going to say this will equal pages. Nope, close that out. That's the filter expression. Correct. And then we're going to return the standard cost. That's what we're going to count. show standard cost. And that's going to close out the count X expression. So if I actually typed that formula correctly, what we should see is an error. Got something wrong. So count filter product related name, and I'm closing the related. Close bottles. Let's say quotes, maybe double quotes are what are needed here. That might be the case because aha, so I'm getting 3. And that's what he sees as well. And so number of, so he's changing the name here. Let's change that. You can see that. So I get 3. I'm not sure what this is supposed to mean, but in any case, we've got it. Now he's saying if we look through this and try to find them, we should see that there are 3 values there. So in using this, let's see how we use this. We'll create a measure. And so where does he want to put this measure? So in his pivot table, he's adding a product and subcategories. So let's come back over here and say this will be our count. And again, we're going to create a table. And we're going to drop in, as we normally do. Let's say if we drop the subcategory first, and then we'll drop in the category. Let's reverse these and see what we have. Okay. And now we want a new measure. So he's going to add the cost, the standard cost. Let's add our standard costing from the product table, which was here, and count product cost. What do we see? We see too many, 1185. I think this is ordered slightly differently. Just getting some different values here. Count of product cost, did I? Sum of standard cost. I didn't add these. That's a measure. I didn't add that product cost one, did I? Because I did it in my table. And this is appearing as a sum. So 82, 255. We don't see that because we don't see the expansion or the. He's got mountain bikes, road bikes. So these are subcategories. Mountain bikes, 15 something. Yeah, so that's the number of mountain bikes, 15010 is here. And then road bikes is 25. 675. Okay, so we have done this correctly. We've appeared there. And the sum of number of standard cost selections, where was that? And so 195 for the road bikes, which is correct. Mountain bikes is 114, which is correct. Okay, so we're seeing those. Now he's going to tweak some settings in there, and he's going to change that to count. So I believe what we're doing is changing to count, not distinct, or just count. It's changing it to count. So what do we see now for values? We see mountain bikes have 38, which is what we expect. Road bikes have 65, which is what we expect. All right. 3. So bottles and cages. 3 and 3, which is what we expect. He's showing there. So he's going to create another calculated field, which I think for us means we need another measure that we're going to use. Standard cost value. The count is generated earnings values for other rows. And I think that's some of that, right? That we're seeing 3 here, even though for this standard non-count of number of standard costed selections, we calculate that as 3 in our model. I come back over here and we say product. That's 3 everywhere for every single product category. So we're seeing something weird, but that's fine. Let's actually do this new measure. And in the new measure, we're going to say we want this. What are we going to call it? Let's use the same name. We're going to use calculated measure, CM. And then for the formula, which we'll have to tweak here, it's CountX filter product, which I think it's in single quotes. So product subcategory in single quotes. Subcategory, English product name. So slight syntactical difference between Power Pivot Excel and Power BI, which is, I gotta say, maddening that would actually be the case, but that is what it is. So let's put this in there as a measure. And then we go back here and let's add that measure to our table. And make it bigger, of course, because that's the advantage. So here we see 3 for the bottles and cages, and it doesn't exist for all the other rows, which is actually correct, right? That we shouldn't see it. So we only see it for bottles and cages. For everything else, we see nothing. Because this measure is specifically tailored to this category, this is what I would expect. I shouldn't see these other ones. So in terms of this calculated column, there's something, these are probably the correct values, but it's a weird count thing that I wouldn't expect. I would expect that I should see 3 everywhere, in fact. I think in homework, I need to read a little bit more about this and better understand what's going on. The next section is actually max and max X. I suspect this is very similar to what we were seeing there in terms of what max does, right? It gets the entire column. Max X is an iterator that allows us to have a function. And so, the max cost would be the same for every row. If max X is an iterator, I could say, give me some different numbers. In this place, calculation, right? What is the max of the amount plus the tax total? What would that give me? And so we see a different amount, right? So if you look through here, 3125 is the max number, and all these rests are not there. In the practice to go through this and try to figure some of these and calculate this out, I'm going to hold this for class 6. And then my intention, I think, let's go down to the bottom here. is for class 6, max should be relatively quick. And then we can do product and product X and see where we stand. And so I'm hoping we could still, if we could do this in 6, get through 7. 7 will be 1 or 2, and then 8, 1 or 2, and possibly we'll have to go to 9. But we'll see where we stand. I know Bill is thinking about adding other articles, so maybe we'll have more. In any case, hopefully you've learned something. I have too, right? Playing with average and count. There's definitely more to learn here. This gets me a basic idea, though, of the fact that using these as a column may not be as good as using them as a measure, where I can then slice them and see what's happening for each of the items in my particular subset of what's going on. So the X function is being used as measures is an interesting way to do this. And then certainly combining the work we've done with filter so that I can get a subset of rows in my model is interesting. So basic understanding, again, these stairways are designed to just get us from the, what would I say? I guess the basics of a very limited view of how this works to, let's close those, to just an advanced beginner understanding and being able to start working with this. There's a lot more to go beyond this, but for now, there's class 5 where we went through the average and count functions, and then we'll see you next time when we look at the max functions, and then hopefully a little farther. Thanks.